Hello, I'm Julian. I play in a punk band from Canada called Inhalants, and I'm building the coolest instrument you've ever seen. This thing is an all-in-one device that's powered by a Gameboy from the 90s, which is going to act as a musical instrument, a stage production controller, an effects processor for my voice, a click track, and also the amplifier for my bass guitar. The goal is to have a totally unique device that is exactly purpose-built for our weird-ass band, and that only I know how to use. For a couple years now, I've been sharing the learning experience, and last episode I went over how all of the electronics interact with each other. You can watch that up in the corner here. And all of the episodes leading up to this have been about my design process. But today, we actually get to make something in real life. So buckle up, bitches, because this is going to be, well, it might be mildly interesting. So now that I have what I think is close to the final design, I need to do some experimentation with the actual real pieces before I put the final touches on the 3D model. This is basically a research experiment so I can learn enough about the physical material and the behavior of the tools to be sure that my design is possible. The main tool I'm going to be using is a CNC router. This stands for Computer Numerical Control, which is a pretty useless descriptor. It's a bad title if you ask me, but basically it's a spinning blade that's connected to some robotic motors that lets you precisely cut a flat piece of material like plywood or sheets of plastic or foam or whatever. The advantage of a CNC is that it's extremely precise and it also saves a lot of time. It's not to say that you can't get the same results with hand tools, but it requires much more time, effort, tools, knowledge, and skill, and I have almost none of those things. When I started this whole thing, I thought that you could basically drop a 3D model into the CNC's control software and it would do everything for you, but I learned pretty quickly that that's not the case. While a CNC is a really precise tool, it's also very stupid, meaning you have to tell it to do essentially everything, and you have to really understand the nature of the tool in order to take advantage of it. Fortunately, I'm pretty good with tools, and you can ask your mom about that. But the purpose of this whole manufacturing step, well, let's look at it this way. So there's the design step, and then there is the manufacturing step, and then there's the assembly step. These are all obviously interrelated, but the manufacturing step has its own quirks and things that need to be handled. And there's a few things I wanted to test because the design is largely influenced by the manufacturing process that you're going to use. So I need to understand how a CNC translates to real life in order to be able to design around it adequately. So there's a few things I want to test. Firstly, I don't want to have to do a lot of hand finishing because, like I was saying, I don't have precise enough tools and I'm also not good enough at it. One thing I really want to avoid having to do is these very precise edge bevel cuts. This is where you like join two pieces of the enclosure at an angle like this. You would normally do these on a table saw, but I wanted to see if we can do it precisely on the CNC. So the way that you do that is you get a V-shaped, this is a V, you get a V-shaped router bit. So it's like a point, like a spearhead, but it's circular and it spins in place. And normally they're 90 degrees. So it's like a corner, and then it's the point that is cutting. And then because you're only using half of it against the edge of the material, you get a 45 degree cut, which gives you a 90 degree joint like you get on a box. But I'm not exactly sure if I'm going to get a more precise cut from the table saw or from the CNC. And on my design, there's some 45 degree angle cuts, which means that the standard like 90 degree router bit won't work for those cuts. So I tracked down a 46 degree V-shaped router bit to try this. The reason it's 46 degrees instead of 45 degrees exactly is because there's always going to be some imperfection to the cut, because especially on wood, because wood is so soft. So in order to make the outer edge come together nicely, you want a tiny bit of air on the inside so that the outer points come together. Otherwise, if there's any imperfections in that cut, it's going to create a visible gap at the outer edge. So here I cut a little test with the 90-degree bit just as an experiment to see how sharp we can get the edge of a piece of plywood. You can see that the grain direction also matters here, because if we cut with the grain, it's not as sharp as the edge. So we did it wrong on this. I have to make sure when we do it in the final piece that we do the beveled cuts against the grain, and that's going to give us a sharper edge. But before I could start cutting, we have like a major issue that I have to resolve. Initially, I was going to build this thing out of 1/2-inch plastic sheets. High-density polyethylene is what it's called. It's like cutting board. But that turned out to be a terrible idea because you can't paint that plastic, and it's crazy heavy, and it has this weird like semi-translucent texture, so it lets a little bit of light through. The plastic is so heavy that if I built it out of plastic, the whole thing would be more than 100 pounds without any of the actual electronics inside it. With the plywood, for example, it's going to be closer to 40 pounds. So that has led me to the biggest grievance of the project so far. My entire design is based on a 1/2-inch material, which is exactly 12.7 millimeters. The closest thickness to a 1/2 inch in this stuff is 12 millimeters, which means that I have to adjust all of the components of my design by 0.7 millimeters, which is going to be so tedious, and also it's going to be prone to failure. Because if I knew what I was actually doing in Fusion 360, the design software that I'm using, if I knew what I was doing when I started, I could have designed it so that I could just change the value of a material thickness parameter, and it would actually adjust the entire model accordingly, which is amazing and basically the whole point of the software. But because I have no idea what I'm doing, I have to sit down and make tiny adjustments to the whole design because my model is not robust at all. So it's not joined where it needs to be. Everything is just floating in space, and I, manually measured the size of everything. So if you know anything about 3D modeling, you know how horrible an idea that is, especially if you've done CAD. But I'm an amateur, so I just brute force everything in my life. Anyway, before I do that horrible revision that I'm dreading, and it's going to take a bunch of time, I need to make sure that the rest of my design as it is actually works. So I need a cheap material that is exactly 1/2 inch that I can use to make a rough version of the final product. That way I have something in hand that I can play with, so I know what needs to be changed in the final design. So I chose MDF, which is this common pressed sawdust material. It's basically super dense cardboard. The problem with using MDF is that materials don't come in normal fucking sizes. You know how a 2x4 is actually like 1.5 inches by 3.5 inches? Well, sheet woods are the same. The 1/2 inch MDF that it's sold as is actually slightly less than 1/2 inch, and because wood is soft, it actually varies by up to 3 millimeters across a given piece. So when you get a 1/2 inch piece of MDF, it's not actually 1/2 inch, it's slightly less, and that variance matters for this design. So if I were to use the allegedly 1/2 inch MDF boards for this, using my current design, there would be little air gaps where the design relies on the thickness of the material. So our solution was to buy a 5/8 thick sheet of MDF and then shave it down on the CNC until it was exactly 1/2 inch. I don't recommend this. MDF is manufactured under pressure. That's how it's made. It's pressed and glued. And when you shave off one of the pressed sides that's finished, it warps pretty hard. So I don't recommend that you do that if you need a precise material. Regardless, it was close enough that I could at least test fit the materials, and that's what I showed you at the beginning. I'm pretty excited to finally get started with the hands-on aspect of this project, so stay tuned for the next episode where we're going to assemble this thing, and we're going to discover all the ways I screwed up in my design. As always, thanks for watching. There's a few of you in the comments that have been following this project for like years, and I can't believe that. There's this guy, L Novice Bassist. He kept coming back and commenting on older videos even though I wasn't currently releasing anything, because he was that engaged in this project. So for you, man, I just want to say that you made me want to keep doing it. This is like taking up my whole year, and it's a pretty dumb project and kind of a waste of time. But I'm really grateful for that. I only have 300 subscribers, most of which are probably inactive accounts, but the few of you that are watching are so fucking cool. Also, for the few of you who actually listen to our music, we've been sitting on a pretty fantastic batch of songs for 4 years, and we're supposed to be recording them with Scott Middleton from the Cancer Bats, but because of my immigration situation, I haven't been able to leave the U.S. for 3 years now, so it's delayed our studio time for that long. I can tell you, though, that what we have written are all certified bangers, and it's way better than the stuff from our old LP. And once this synth is done, it should be a pretty awesome creative opportunity. So get ready for Inhalants to stop being the best band you've never heard of, because we're about to become one of the worst bands you have heard of. All right, I'm done. See you soon.